All right, so here we are. We're coming into the final stretch. I think we just have 60 and 61, and then we have can call it a day on test number 3. But if you look at 60, 60 and 58 are almost identical. We're just using different numbers. So let's go ahead and jump right in. We have a farmer has 240 yards of fencing to enclose a rectangular area of 3,500 square yards. What dimensions should he use? All right, so again, we got some farmer probably trying to fence in a field or some sort of crop, probably animals, livestock, right? Hence why we're using fencing here so they don't escape. But at any rate, we know that the area of this field, I'll just call it, is 3,500 square yards. And again, we know that because this is a rectangle, we have a length and a length, we have a width and a width, and the perimeter, right, which is really what we're talking about here, if we're talking about fencing in this enclosure, the perimeter is the sum of all of its sides, the sides here. So we have L plus L, or 2L, plus W, or 2W, equals the amount of fencing it's going to take to enclose this area, also known as the perimeter, so 240 yards. All right, and we've also been given the area. We wrote that here, and we know that area is length times width. So length times width here is going to be 3,500. All right, and now let's go ahead and use what we learned in the previous chapters, right? The system of equations to solve for either L or W. So we have, let's go ahead and, we're running into the same problem that we did in 58. If we started with this equation, we'll end up with a fraction, right? If we solve for L, we'll have a fraction. If we solve for W, we'll have 35 over L, so a fraction. So let's start here. And we can go ahead, and how about this time we solve for W? I think we solved for L last time. So we'll subtract 2L, subtract 2L. That leaves us with 2W equals, and now 240 minus 2L. And we'll divide by 2, we'll divide by 2. And so we end up with W equals, well, 240 divided by 2 is going to give us 120. And 2L over 2, the 2's are going to cancel, so we're just left with L. And so there we have it. All right, so W equals 120 minus L. So let's go ahead and take that information, plug it in for, oops, not for L, we just solved for W. So let's take it and plug it in for W. And now we'll rewrite this equation. So we have L, and now we're replacing the W with its value. So 120 minus L equals 3,500. Let's go ahead and distribute our L through. So we have L times 120, that gives us 120L, minus L times L is L squared, equals 3,500. Well, we've got ourselves a quadratic equation again, don't we, right? When we know that because we have a square term. So let's get all of our terms on one side and set the equation equal to 0. Again, our squared term on the left is negative, so let's go ahead and add it to both sides so that it's positive. And at the same time, we'll subtract 120L, we'll subtract 120L. And rewriting this now with the terms on the left in descending order, we'll have L squared minus 120L plus 3,500 equals 0. All right, now that we've got ourselves a trinomial set equal to 0, we can start and say, is there a GCF? Nope, don't see one. So question number 2, how many terms? Well, we just said it's a trinomial, so 1, 2, 3. So AC method, trial and error, factor using scissors. But because the coefficient of our squared term is 1, really we're just looking for factors of 3,500 that add to give us negative 120. So I know we're starting to use bigger numbers here, but remember, you're going to have your calculator with you, so we can hopefully relatively easily find some of these factors. But first and foremost, we know we're working with L, so let's go ahead and just split that L up. And 3,500. So let's see, I guess what you could do is start with, let's see, 3,500. We want the factors. Obviously, we don't want to start 3,500 because there's no way we can add those numbers together to get negative 120. So don't start small. I would start with maybe 100, just see. So we know that 3,500 divided by 100 is going to yield 35. And we want these two numbers to add to negative 120. So we're getting close, but not quite there. All right, so we know that 100 is too high. So let's cut it in half and see what happens. So if we divide 3,500 by 50, we will get 70, right? Because 5 times 7 is 35, and then you add your two zeros. And this actually happens to work, right? Because we can multiply 50 times 70 to get 3,500, and we can add these two numbers together to get negative 120. So negative 50, negative 70, and there we have it. If that didn't work, try something else. Maybe try 75 or try, 35, or just start, punching in numbers. And again, you want to start with larger numbers because you're looking for the sum of your two factors to be a pretty large number, right? You're looking for it to be 120. So we know that it's, not going to be 1 or 2 or 5. You've got to start much higher than that and then maybe kind of start working your way down a little bit. All right, but nevertheless, here we have it. So let's go ahead and get rid of this work here. Oops, give us some room. Oops, keep hitting the wrong button. All right, so now we have some room to work. So we have L minus 50, L minus 70 equals 0. We'll set each of these factors now independently equal to 0 and solve. So if we add 50 to both sides, we know that L equals 50. We will add 70 to both sides. L equals 70. All right, and they're both positive, so that's good, right? Because we're dealing with dimensions here. So dimensions means distance. We're measuring an actual, distance or something that can't be negative. So since we have two positive numbers, that's good. And let's go ahead and we can take each of these answers and plug that back into our little diagram here. So if we say that we want the length to be 50, well, we know then that the width has to be 70, right? Because 50 times 70 would give us our area of 3,500. Or if you want the length to be 70, we know the width has to be 50. So in this case, these really are your numerical answers. So the dimensions here are 50 by 70. And again, because they don't specifically ask you what are the lengths of each side or what are the width of each side, you're just asked for the dimension. So you can say that the length is 50 and the width is 70, or you can say the width is 50 and the length is 70. They're not really asking for specificity, they just want the dimensions. And so once you solve this quadratic equation, you really have the numerical answers, 50 by 70, and that's all you're asked for. All right, so that was 60. I think we've got one more, and we'll take a look at it, and then we'll be good to go.